Presenter is the author of Mod WSGI, which is instrumental in developers being able to deploy Python to the Apache web server. He's also a member of both the Apache Software Foundation and the Python Software Foundation, so he keeps very busy. And his regular day job is as a developer with New Relic. So if you could all please give a warm welcome to Graham Dumpleton.
Thank you. This talk's actually being prepared. I'm giving a presentation now, but it's actually I've got some assistance in preparing it from a guy called Amjif, who's working with me at New Relic. He started recently. He's actually going to give this talk at DjangoCon in the US as well in a few weeks. Now, if you did want to follow along as I went on the slides, you could go up to SlideShare, but because of the network issue, it stopped about there when I tried, so it only got up to 85%. I will try again to upload it later so that you can look at the actual charts a bit more in detail. So you've written what you believe is the most amazing website in the world and you deployed it to production. Real customers are using it, it's making you money for you, but something is going wrong with it. You don't quite know what, and because it is a real live production website, you can't necessarily go in and just start playing with it. What are you going to do? How are you going to debug the problems? For some types of problems where you get a nice Python exception traceback, the cause may be obvious. But the cause of other things such as data corruption, memory leaks, thread locking, and issues in general performance problems can be more elusive. Trying to duplicate issues in a development system can sometimes work, but more often than not, your problems are only going to show up once you deploy your code to production. As developers, we would love to be able to just dive in and start poking around in the live web application, but operations staff aren't going to like that one bit. They get very nervous when you say, I want to do this or that. If we're going to try and do things with a live web application, it has to be things that aren't going to make things worse. The results of things we do need to be predictable, with the effect of doing them able to be validated in advance so you can test out what you're going to do. Whatever we do, it's all about managing risk. We don't want a loose cannon that is going to cause more damage than good. There is no reason, though, why we can't do things which do have some level of risk. We just need to be controlled in what we do and make sure we understand the consequences. If making changes, script the actions you're going to take, test them beforehand, and develop contingency plans to cope with when things do go pear-shaped. The most benign thing you can do is passive monitoring. That is where you set up in advance mechanisms to collect data on a continual basis. In the event of a problem, you at least then have some forensic information to try and analyse what went wrong. Monitoring can take many forms. This can include collecting log files, details of application exceptions, or quite specific performance data. In the case of log files, they can come from many sources, including the operating system, your web server, your web application, back-end application services and databases. These can be spread all over the place. To make sense of them and make it easier to find and correlate information, various free and commercial products exist to help. These tools, in simple terms, are search engines for log information. Log file analysis can only work, though, if the application actually logs something about an event. If in web applications in particular, exceptions often are translated to a generic HTTP 500 error, and no details are logged. In this situation, an extra step needs to be taken to configure the framework to record details of exceptions, or to add in additional tools which can intercept exceptions and report them back to a service for storage and later analysis. When we move up to server monitoring, there are a range of open source choices. What these monitor can be quite extensive, but they can also be quite hard to set up and manage depending on the product. For many users, the simplicity of a pre-configured solution can be just as beneficial, if not easier to deal with, than a highly configurable and highly complex solution. So your mileage may vary depending on the product you choose. So shop around and see which one works best for you. Want to dive deeper into what's going inside of your Python web application, and that's where I was obviously going to say that New Relic is your friend. In addition to providing server monitoring, New Relic provides real user monitoring and application performance monitoring. For your web application, it gives a deeper level of introspection into where time is being spent within your application code, as well as including time spent calling out to external databases and web servers. So you can easily bring together a set of monitoring tools. The question then is, what value are they in debugging an issue as opposed to telling you that there is a problem in the first place? The big ticket item with websites is performance. A high-level view which looks across end-user time, application time, and that of back-end services allows you to quickly drill down to where the problem may lie. End-user monitoring can help you realise that the actual issue is with the page content you're generating rather than the mechanisms of generating it. From there, you can use various web page performance analysis tools. But keep in mind, though, that these operate not from the perspective of your actual users, but where the online service is located, or if you're using a browser-based one, where you are located. In the future, advances like the browser resource timing specification coming out of the World Wide Web Consortium could make such analysis more representative of what real users are seeing, as it then would be technically possible to report such information direct from user browsers, giving you a much larger data set to work with, because you are literally pulling it out of the user's browsers. What now for where the problem is in your application? If using New Relic, you can start to drill down and look at performance of individual request handlers, seeing their throughput and response times. You can also get a more detailed view of individual sample slow transactions. The performance breakdown in a slow transaction summary gives you a high-level overview of where time is being spent for that specific slow transaction. The summary, though, doesn't necessarily provide you with any context of where in your code the time-consuming operation was made. Some level of context can be obtained by drilling down and looking at the details of slow transaction traces, but it is limited to those functions which have been deemed of interest by us in producing the agent. It needs to be limited in this way to ensure that the overhead of monitoring does not impact the performance of your application. If we were to do full profiling, it's just going to be too much of an overhead and it's going to kill your whole web application, and that's why we need to be selective. So because instrumentation is targeted only to areas such as time spent in middleware, view handlers, template rendering, and template blocks in Django, for example, eventually you get a situation where you get blocks of time where you lack sufficient detail. This is where monitoring tools can need a bit more help for you indicating what else is of interest in your specific application. You have a few choices of how you can do this in New Relic. The first is to make changes to your actual code base. So you can apply function decorators to existing functions, or you can use context manager objects to time within blocks of code within a function. Such changes are obviously intrusive though, which could be an issue. Plus it also doesn't help when you want to time how long it takes in third-party code, which you can't easily go in and modify. A second approach is to nominate functions of interest by way of a configuration file. This avoids you needing to change code and saying can be used with that third-party code. But you're very simplistic here. You can usually only just do very simple function tracing. A final option is monkey patching. Here you can specify a function to be called when a specific module is imported. That function would then go in and monkey patch the code. And this gives you a lot more flexibility of what then you can actually do. Whichever of these approaches is taken, the problem here is that to get the added visibility, you need to make a change of some sort to your code and redeploy it and restart your application before you'll see the additional instrumented functions. So the problem is it does not provide you the here and now way of delving down into a problem at the time that it's occurring, because you may go and change your code, restart it to capture this information, and then it's no longer occurring as a problem because it's been dependent on the history that has occurred up to that point in your application. A partial solution is what they call thread sampling, and this is where you would go in and start up a profiling session. That takes a periodic snapshot of what each thread is doing at a specific point in time. And from that produce a call tree showing what percentage of time code at a specific point was executing. Unfortunately right now, New Relic at least, we don't do that for Python, although it is something we've been looking at. But there are separate thread sampling tools that do exist. Dropbox recently announced Plop, along with a pretty visualization tool to try and start making sense of all that data you're getting. Another is StatProf, which advertises itself as being able to trace down to line level, which I believe the Plops only perhaps go down to function level. Anyway, the premise behind these sampling approaches is that the overhead is lower than traditional full profiling, such as provided by the Python profile modules. So whereas full-on Python profiling can't be used in production application, then something like thread sampling could. Ultimately, thread sampling is still an estimate though. It's not as accurate as full profiling. A middle ground though is not to run profiling all the time, but collect samples there as well. So that is, don't profile the whole program, which is what people traditionally do, Target specific functions and only collect a full profile sample for a call every so often. We could, for instance, have the criteria be that we collect samples at minimum of 1 second apart and write out the aggregated results after 30 successive calls. And that way we're imposing a much lower overhead on your production web application, because you're just not doing it very often. But it still gives you a representative sample of better than a Fred sampling of what's going on, what you need to look at. So this can be achieved using the C profile module, a decorator, and a bit of context manager magic. We just need to add in a gating mechanism to control how often it is done, and we can achieve that full profiling for a function of interest. And because I said because it's done infrequently enough, then the overhead imposed on the production web app is not going to be as bad as full profile of the whole application. Now, New Relic is by no means the only way of instrumenting web applications to collect metrics. Although it is arguably gives you a lot of value out of the box with immediately actionable data, because we go in there and target, say, Django as a framework, and we go and add all this extra stuff in. But whatever the solution it is, whether you use some of the other ones I've listed here, which again, you're going to have to do everything yourself manually to actually collect all the data, you still need to manually modify your code to add that extra instrumentation you want to further explore a problem when you've got an issue occurring in production. So you still need to go and redeploy your web app. So getting more in-depth useful data can therefore be a long process. And this is the problem we've got to solve. Monitoring can go so far, but to get that more out of the monitoring at that point in time, it's what do we do? So what is lacking is the ability to prod your live web application to get it to start yielding that additional data while the problem is occurring. Some tools give you this interactivity, but they're only suitable for development environments, as they display the data back in the browser the request is made from. Sentry does provide separate analysis of tracebacks and stack variables after the fact, but we still don't have a way of changing the way the application is running. Application backdoors to affect change are not new. The logging module in Python even supplies such a backdoor. Enable this and it will listen on a socket for connections and allow you to pass the application a new configuration for the logging subsystem. Dangers do exist with such mechanisms though. The logging module actually runs eval on parts of the configuration file, meaning that you can actually inject arbitrary code into your application. And I actually only found this out a couple of weeks ago when I was digging around the logging module. Sending emails to the Python security list. Okay, they didn't feel it was that bad of an issue, so essentially a bug got put on the bug tracker, and they've gone and changed the Docker to warn you about it at least. But it was a bit scary when I saw that one the first time. A bit unexpected. But if you are concerned about arbitrary execution of code, well, you could actually instead elect to expose a full embedded Python interpreter prompt. And various things like eventlet, heapie, and twisted manhole do have that ability. You can go a step further again. You can have the rather scary concept of parasite, which uses GDB to perform code injection into an arbitrary, unmodified Python process. I believe that as long as you don't have it fully stripped, optimized, I'm pretty sure it works. But we want something that allows real-time interaction, but also want that access to be more controlled than a full-on interpreter or debugger. So providing this means for interactive access to a running process is something I've toyed with for many years, and in trying to help people debug mod WSGI particularly. So following on from PyCon US this year, where Adam Lowry gave a talk on a thing called Socket Console, where he again talked about backdoors and using it to get stack traces out for the different Python threads. I finally got to sit down and actually create something which bundles up all the ideas I've been playing with over the years. So I created this package called iSpied. It was originally intended just looking at WSGI applications, but it sort of turned into a thing which is suitable for other applications as well. So that's why it says WSGI shell on GitHub, but it's actually called iSpied inside. So depending on your application architecture, the process here, when we embed iSpied into it, would listen on either an internet or a Unix domain socket. To hide the details, you've got an iSpy client program is used to make the connection to the actual process. The command interface is driven using the command module from Python. And once you can connect it, you can list all the plugins which you have configured the system to make available. Because rather than sort of like jumping straight into an interpreter, as what the other people have done, the whole point of this was let's try and make this controlled interface. So let's have it based on plugins and so on and control it that way. So we can change the context of a specific plugin, and you can then issue the specific commands which that plugin makes available. Because it isn't that full interpreter, you can control what the plugins you have enabled and therefore those commands. This way you restrict what can be done and ensure that you can't do too much damage by virtue of just not putting the things in there that can. If you are addicted to that power though, then no problem. You can go into the configuration file, and for the Python plugin you can say, I want to enable embedded interpreter support. And once you do that, you can go in there and still run up a console and do as much damage as you want. If you are comfortable with monkey patching a live web application, there are a range of other things one could do. One could introduce a wrapper that captures details of exceptions and enables you to perform post-mortem debugging within the live process. This is similar to tools like the Flask debugger, but done using PDB directly in the live process. Finally, monkey patching can also help with our original problem of how does one change what is being monitored by a live web application without a restart. With an interactive console like this, it becomes feasible to have commands that would allow us to monkey patch the live system to add those additional function traces that we're trying to do for a configuration or otherwise before. That would only exist until the process exited, but it does at least provide you some coverage of the problem until you can make that permanent change in your code and redeploy. A further problem area with monitoring, where monitoring can be useful, is answering the perennial question of how many processes and threads should I configure my WSGI server to use. Capacity can be viewed relative to normal traffic loads, but it could also be used to gauge whether you have sufficient capacity in a farm of servers when you need to perform a rolling restart during a deploy. If you've done your homework and have the available capacity, then although you'll see a jump in how much your capacity is used when some servers are taken offline, the effect on application response times will not be affected. Get it wrong though, and you could start to see a backlog with an increase in request queuing time, overall response times growing, and customer satisfaction basically going down the drain. A further cause of backlogging due to increased capacity is when requests block and the effective number of available threads drops. Monitoring systems will often only report on a web transaction once it completes. If a request never completes, you'll not get any metrics about it, nor a slow transaction trace, so you're not going to know about it. So this again is where an interactive console can help. In particular, you could run a command to dump out the details of all active WSGI requests, including the environment details and a Python stack trace of where the code was in that point. So all you need to now do is go find those transactions which have been running longer than the expected amount of time, and you can see where it is, what it was doing, and why therefore it may have blocked. So being an interactive console though, we can only talk to one process at a time. What do we do about multi-process web applications? Obviously, if interacting with an embedded interpreter or a debugging session, there's not really much we can do. But if we only wish to dump out the details of what a process is doing or perform monkey patching, what we want here is an ability in the client program to automatically apply a set of commands across a whole bunch of servers in one go. And that's giving us our scriptability. Because the console-oriented interface and the command module in particular is being used rather than trying to wrap up things in some high-level message-oriented service abstraction with this whole thing, writing new plugins is relatively easy. All that is necessary is to provide a method for each command that writes the response to the output stream object set up for that instance of the shell. And for more complicated plugins which require further input, such as an embedded interpreter, the input stream is also there available. So jump in there and extend it. So the whole point there with iSpy when it got it was not just to be another interpreter, way of getting interpreted. It was this whole thing of a general infrastructure for managing a console and interaction with a process. So the goal then hopefully is that the wider community here will sort of go, oh, this is a really good idea, and we'll start to have all these plugins get made, which will be available from PyPy. You just download them, install them, list them in the config file, say that you want them, and away you go. So one could see lots of useful plugins being developed. A good in-process memory analysis tool for tracking memory growth would be example here, which would be particularly interesting and valuable, and where, again, monitoring systems, although they can show you how much memory your application is using, they're only going to necessarily report on it once a minute, for example. So you can't see the little transit things that are going on between, and nor can you get the in-depth detail on things like how many objects have been created and all those sorts of things. So monitoring systems, yeah, they give a good overview, but that's one thing I don't have a good answer on yet. There is HeapI, which is frightfully complicated in my view, and it tends a tendency to crash processes I've found. So hopefully iSpy will be a nice mechanism for people to come up with a nice plugin for memory debugging. It'll be really good. So in conclusion, what am I trying to say? That is that production systems need not be treated as this special sanctum that only anointed operations people can touch. Use monitoring systems so you know what problems arise, but be prepared and also put in place mechanisms to help you debug the issues that do arise. Do it in a way that is controllable and scriptable, so that the results are predictable. Doing debugging then becomes a normal procedure in the same way that deploys are, and your ops people are not going to get freaked out when I say I want to do this. So obviously we'd hope that you would see New Relic as part of your tool set when you're doing all of this. But whatever you do though, use some level of monitoring. If you have no monitoring at all, then you not only will you not know immediately when there is a problem, but you will not even know where to start looking to debug it. So become a data nerd, deploy New Relic, and if you're interested in iSpy, then come and have a chat to me afterwards.
We have a few minutes for questions, so if you do have questions, please wait for the mic to come around. Just stick your hand up and Mark will run the mic down to you. Any questions?
Hi. I was interested if you could think of any stories off the top of your head of when you've used iSpy or iSpied to...
iSpied, yeah.
Okay. To just, I guess you've discovered particular sort of memory leaks or performance issues where you completely didn't expect it.
iSpy is something I put together mainly that when people ask me about ModWS show problems, I can be prepared and say, hey, look, go put this thing in, and then I can tell them what to do. Fortunately, instead I did it. I've not actually had anyone come up and need it. But what I have done is the whole concept of that embedded console is something that I've taken and for our New Relic Python agent, I've actually got a variant of in our agent itself. And one of the things we've been looking at is how to support async applications rather than just blocking WSGI apps in our Python agent. And yeah, one of the customers was trying to trial some of the stuff we were playing around with there. They would find that this twisted instrumentation, it was all working, and then suddenly it would stop. And I had no idea. So this is an example where with the interactive console, it was good. I could say, oh, deploy this new version of the agent I've got, which we're about to release soon, configure this to be enabled. And when he had the problem, I could tell him to go in there, and we'd pre-set up all these commands, which would allow us to dump out information about what our own agent was doing. So we could see that, oh, it was, at this point in time, it was had this one active web transaction which it was monitoring, and it somehow lost, sort of got stuck at that point. It got, like Twisted is really weird because in a WSGI app, everything's in separate threads, and therefore we can track each web transaction individually. But in async app, you've only got one thread, so we have this web transaction record, which we sort of keep having to pop off the top in terms of the current one. So it would end up getting left there. And meanwhile, the transaction had finished, and because it was the current one, the whole system got confused, and a new one's come along and it wouldn't do anything. So that was an example where I was able to use this interactive console to at least confirm what I thought was happening in their app. And from that, I was then able to do a bit more digging in the code and work out what was probably happening. In that particular case, I still haven't actually fixed it. I told them to disable this bit of instrumentation, and at least they're getting overall response times, but they're not getting deep information on twisted deferreds at the moment within the context of the web app, which is a bit unfortunate. But yeah, that's an example.
Okay. How long has iSpy been around, or how long?
I basically got all the bits together and shoved it in the repo back in Easter long weekend, but I haven't publicised it. This is the first major outing, just to say it. It's not finished. Like some things in there, like this idea of being able to apply a script of commands across multiple servers isn't implemented yet. It's the idea. It's what I want to achieve, and it needs some cleanup. But this is where I'm putting it out there, and hopefully it'll get the interest to people might want to start contributing on it, because at the moment I'm really busy and I haven't had time to go back to it.
Cool. Well, thank you. Looks bloody interesting, yes.
Anybody else? No? Graham, are you hanging around for the hackathon afterwards?
No, unfortunately I have to go back up, leaving Monday lunchtime.
Okay, cool. Just wondering, because it would be good to work on. So I've got a couple of things to give you for thanks. Thanks, Graham.
Thank you.
Some coffee in a coffee mug. Thank you very
I'm
much.
sure I'll find someone to
And
drink that.
round of applause, Graham.